Lesson 1 is on relations. So, relationships occur everywhere around us. One such relationship you may be interested in is the relationship between your salary and the number of years of post secondary education you have. This obviously isn't perfectly accurate, but the idea is that depending on how many years of post secondary education you have, you would have a starting salary that may be different. This is just representing that these would be our x values, or this would be our independent variable, and these would be our y values, or our dependent variables. 3 years of post-secondary education would lead to a starting salary of $30,000. We have x values and we have y values. We can also display this data as a set of ordered pairs, and you're familiar with ordered pairs, always x and then y for an ordered pair. The first coordinate here would represent the number of years, and the second coordinate would represent the salary. So a relation can really be anything where we are relating elements x in a set A with one or more elements y in a set B. This rule creates a set of ordered pairs. So if we have any set of ordered pairs on a graph, we can call it a relation. So the set A, which is the first coordinates in the ordered pairs, it's called the domain, which you might be familiar with when you studied quadratics in grade 10. And set B is the set of second coordinates in the ordered pairs, and that is called the range. So in the above example, the domain is 3, 4, 5, and 6. So we just state our x values of our relation, 3, 4, 5, and 6. And then our range is the set of the y value. So this first example, relations f and g are defined as follows. So this is the relation of f, and there's a set of ordered pairs. This is the relation of g, and here's a set of ordered pairs for g. What is the domain and range of each relation? So this is very introductory. This is just because it's the first time we might be defining what domain and range represent. I would just say the domain of f is all of the x values from each of the ordered pairs in the relation f. The range of f will be all of the y values, and we just list these. If any y values repeat, we wouldn't list them twice, and usually we write our numbers in ascending order. If we want to look at the domain of g, g is a different relation. The domain of g would be just all of the x values listed in each of the ordered pairs, and the range of g would be all of the y values listed in the ordered pairs. So you can see there that the domain, I saw that the 3's repeated, so I only really had to list the 3 once in my set for the domain. And the range, the values weren't completely in order, so I did put the 1 first, and it's just a typical thing that our numbers would be listed in ascending order. So there's going to be a little bit of discussion now about the domain and range of different types of relations. So this one, I see an equation. First of all, we're going to just graph this. I see an equation. That is a linear equation. So we could say that this is a linear relation, which you studied a lot in grade 9 math. This looks like y equals mx plus b to me. This would be my y-intercept, or my n-intercept, and then I have time, or number of minutes, across the x-axis. So one thing that I might do to graph this is that I put on the y-intercept of 100. I know that that's where my line starts. To figure out the x-intercept, just as one example, the x-intercept, if I let y equal 0, I guess I'm saying y, but really it's n. If n equals 0, I'm able to solve for t. So if I move the 100 to the left and then divide both sides by negative 0.25, I can see that the t-intercept is 400, so I know that it's going to cross the x-axis at 400. What else could I do? I could sub in another number like 200 in here, and then I know that let's say a quarter of 200 is 50, so 100 minus 50 is 50. So I can find other points. I don't need 10 points. All I need is a couple of points that I could connect to make my line. So if we were asked here to state the domain and range for this relation, this is a linear relation. It creates a straight line. How are we going to talk about domain and range for this? So this is different. Up here, we had a set of distinct points. These points were not connected to make a line. These are just separate points on a graph. And so therefore my domain was just 1, 2, 3. My range was 5, 6, 7, and these were separate points. When you have a line, we have points in between all of these points, right? We have an infinite number of points between our endpoints of this line segment. So we can't just start listing the x values of the ordered pair, for example, because there are an infinite number of x values and an infinite number of y values in between, let's say 0 and 400 along the x-axis, or in between 0 and 100 on the y-axis. I know that the domain is equal to the set of t such that, you might remember seeing that, 0 is less than t, less than or equal to t is less than or equal to 400. And t is an element of all real numbers. Okay, what does that mean? So time is our variable such that, I say it this way, t is in between 0 and 400. It can actually equal 0, it can equal 400. So we have our less than or equal to symbols. The reason I'm saying t is an element of all real numbers is because I also want to include all of the decimals and all of the fractions and everything in between my integers, let's say, in between my positive numbers between 0 and 400. Those are not my only numbers. I have all of the elements of all the real numbers in between as well. And then for the range, we're looking at our vertical or our y values. So when we look at our vertical axis, our range goes from 0 to 100. So n is the variable for our y values. So we would say range equals the set of n such that, and I like saying it this way, n is in between 0 and 100. And also, n is an element of all real numbers, all the decimals and all the rational, irrational numbers in between. Okay, example 3, we're back to some distinct points here again. These are both relations, and we can look at the domain being, for this one in part A, all of the x values that we have listed in this relation. So again, these are distinct points. So I am going to just list all of my x values for the domain. And for the range, I'm going to list all of my y values. So vertically, this first one, for example, is at 2. The lowest one I see here is at -2 vertically. So vertically, I am listing all of my values. The highest one is 3 and the lowest one was -2. So this is how I would list the domain and range when I have distinct points. This one over here in part B, I see that horizontally this circle has values along it that go all the way from -3 up to +1. So all of these values and all the values in between, and they're connected to each other. So the domain for this circle is equal to the set of x such that x is in between -3 and 1. And x is an element of all real numbers because we're talking about everything in between the integer values as well. Notice over here I didn't have to say x is an element of all real numbers because I am not including any of the points in between. because these points are not connected on that graph. The range here is vertically, I see that this graph goes from -1 up to 3. So the range is equal to the set of y such that y is in between -1 and 3. And y is an element of all real numbers. So we have a relation here in the next example that is a quadratic. You might recognize that. That's a parabola on a graph. And if I imagine graphing, which I don't have to graph, but I know that my parabola is moved up to, and you can sometimes graph with a graphing app to check this out. And the vertex is the point 0, 2 right here. So if this is a parabola that goes on and on and on forever and it's opening upwards, this would be the lowest point of that parabola if I'm thinking about vertically. If I want to think about horizontally, so the parabola goes up from 2, horizontally, parabolas get wider and wider and wider as they go up. So they kind of continue, and in both directions, they're going to get wider and wider. So what ends up happening with a parabola is that it will eventually completely cover all of the points along the x-axis. So our domain for parabolas is the set of x such that x is an element of all real numbers, and that's all we have to say for domain. It's going to be all of the values on the, it's going to cover all of the values along the x-axis. So everything to the left and everything to the right. The range is different though. When we're talking about range for a parabola, this parabola is only going to start at 2 and it's going to go up from there. So we can say the range is a set of y such that y is anything greater than or equal to 2. And y is an element of all real numbers because it's everything in between. But it's never going to be lower than 2 vertically. So domain is always x such that XER for parabolas, and the range is always going to be greater than or less than, depending on if the parabola is opening up or if the parabola is opening down. This next one, we haven't learned how to graph these yet, but we will in this unit actually learn how to graph these. But for now, let's just look at this equation. This equation, what we know about square root signs, we know anything under that square root sign, in order to get an answer for y, we have to have a positive number. Remember that you can't find the square root of a negative number. It'll give you an error on your calculator. So I know whatever's under this square root sign has to be greater than 0. So that is also called the radicand. The 2x plus 1, whatever's underneath the square root sign is called the radicand, and it has to be greater than 0. Or it could also be equal to 0. We could take the square root of 0, which is 0, and that's okay. So we know that 2x plus 1 has to be greater than or equal to 0. So what does that mean? If we solve this for x and move the 1 to the other side, divide both sides by 2, x has to be greater than or equal to, -1/2. If that is true, if x is greater than or equal to -1/2, the y then will always be greater than 0. So our domain is going to be the set of x such that x is anything greater than or equal to -1/2. It has to be greater than 0 so that we're able to find the square root. And the range, we know, is always going to be 0 or greater. So the notation for domain and range is going to be really important to practice. Sometimes you have values that are greater than a certain value. Sometimes you have domain and range that include all the numbers horizontally or just greater than a certain value. Sometimes you might just have values that are in between two values, Or we can also see values where they are distinct and we just have to list them. So this is really important to practice. Eventually you get more comfortable using this notation.